So in this last topic in our unit of scientific literacy, we'll be looking at 1.4 scientific ethical standards. Confuse the F and TH there. All right. The main goal with this lesson, as we'll see here, is that sometimes people abuse or misappropriate or malalign science for their own specific nefarious purposes, whether those purposes be immoral, unethical, prejudicial, racist, or bigoted. And it's unfortunate they take they take a legitimate academic discipline such as science, they take legitimate scientific research, and they use it for immoral and at times prejudicial purposes. So that's what we'll take a look at today is examples of where science has been abused in the past for such immoral purposes and unethical purposes, and then how can we prevent such things from happening again? Okay, such horrible events from reoccurring. Okay, for the students that were in class, we did this good or bad activity where we kind of had students classify these statements as good or bad, and then we discussed what specifically made us choose good or bad. Okay, so for number one, we looked at the potential benefits of nuclear physics far outweigh the potential consequences, and this is a very and you'll actually see if all these are all kind of very vague statements. These are all statements that you can make a case for or against. Okay, so on the potential benefit side, research into nuclear physics and nuclear chemistry, aka the makeup of the atom in the atomic nucleus, has yielded many positive benefits for humanity. Specifically, we have developed technology over years that has allowed us to produce nuclear energy, which has become increasingly safe and increasingly reliable, which is a good thing because nuclear energy does not give off carbon monoxide or carbon dioxide and pollutants into the air as coal burning plants do and traditional means of energy production. Okay. On the other hand, we also have for other potential benefits, we have nuclear applications to medicine, specifically CAT scans, PET scans, radioactive isotopes that can be injected into veins in order to chart blood vessel maps, and then we have the big one, which is a nuclear MRI machine. These are all examples of how nuclear physics can be used to develop non-invasive medical procedures in order to detect things such as diseases, detect blood clots, potentially lethal blood clots, detect cancerous growths, so on and so forth. But then we also have, on the other hand, we also have potential consequences, okay? Excuse me. Such as nuclear proliferation, where we can have atomic weapons that fall into people who have immoral or unethical intentions with those nuclear weapons, as was a common fear during the Cold War back in the 1940s to late 1980s. And then we also have the fact that if we do not follow safety guidelines with nuclear power plants, we can have very horrible consequences and very radical consequences for not only humans but also for the environment, such as the 3 Mile Island incident of, I believe, 1979 outside of Harrisburg, Pennsylvania, and then also the Chernobyl incident of 1986 in Chernobyl, Ukraine. I do believe it was 1986. All right, number two, genetics should be used to improve the human gene pool by excluding undesirable genes. So we have a good mix of yes and no here. Some people said yes. There are genetic disorders such as Huntington's disease and trisomy 21, also more commonly known as Down syndrome, that are caused by mutations in genes. In addition, cancer is caused by mutations in genes that causes essentially runaway growth in cells and causes the cells to become cancerous. So as a result, if we can exclude these undesirable genes through gene editing and gene therapy, that's better for humanity because we're removing genetic disorders and removing genetic mutations. But on the other flip side of this, we had students who very rightfully noted and very keenly noted that undesirable genes is a subjective statement, meaning that it's based on a person's interpretation of what constitutes an undesirable gene. So unfortunately, throughout history, there are people who have abused genetics, and they've used the legitimate field of genetics in order to justify racist and immoral and prejudicial beliefs by saying that people with XYZ color of skin or people with XYZ sexual preference or XYZ ethnicity are undesirable because they have behaviors associated with their genes that give them their skin color, their ethnicity, or their sexual orientation, and thus we should remove those people from our society. In the most extreme cases that we've seen of that is the enactment of racial purity laws in Nazi Germany that use genetics as their basis. Again, it isn't that genetics is a bad field, it's that these people who quite frankly didn't even have a good understanding of genetics, they had a very superficial understanding, looked at genetics from a very basic primitive level and decide they could use that to justify their racist and prejudicial beliefs, okay? So the Aryan purity laws of Nazi Germany, one example, and the other example is that this superficial understanding of how genes work was used to justify the implementation of Jim Crow laws in the United States in the early to mid 1900s, which for those of y'all who aren't familiar, that was those sets of laws were a set of laws that were extremely racist and prejudicial and meant to discriminate against African Americans. It's absolutely horrible. Number 3, human experimentation is legitimate so long as the results yield positive benefits for humanity. So we had a minority of people say yes, and then we had some people say it's good as long as the person is informed of the risk of the experiment and the person gives their consent, which is an excellent point to bring up that we'll look at down the line this unit. And then we had some people very emphatically say, no, this is not right. The ends do not justify the means. All right, for those of y'all unfamiliar with that expression, that means the ends justify the means is a statement that was found in a work written by an Italian Renaissance statesman by the name of Niccolo Machiavelli. And basically the idea behind the ends justify the means is that you can carry out any action, no matter how immoral or how unethical, so long as the action has some positive benefit for all of humanity. Now, that is a statement that we do not want to see, because that means we carry out any action, no matter what the effects have on individuals, so long as it has benefits for all of humanity. Okay, we don't want to see that happen. The risk to any one life is immoral and unethical. Okay, so same thing of human experimentation. Okay, human experimentation, such as medical clinical trials, is how we test out new drugs. First, we start on animals first off to make sure it's safe there, and then we bump up to humans. But again, as some people noted, the humans have to be aware of their risk, and they have to be giving their informed consent with the experiment. Okay, so as a result, human experimentation is only legitimate in those cases where the humans are not going to be at significant risk, and if there is some risk, albeit not significant, the people participating are aware, and they do give their consent to participate. We can't just slice up any human in surgery and test them without anesthetic or something like that and claim that's legitimate just because we found something positive as a result of doing this. So that's completely unethical and completely dangerous and very, very reckless. And lastly, a falsified study is acceptable if it somehow leads to correct and beneficial studies. Again, this is another example where the ends justify the means, where people say ends justify means. It doesn't matter if the study is falsified because it led somehow to correct and beneficial studies. But that's not how science is done. All right. In science, we base things off accurate data. And we base things off our logic and understanding. If we have a falsified study, that means we don't actually understand what's going on. It means we've just made up the numbers in order for whatever purpose, like we saw back in 1.1. And if this is a practice that's carried out by the whole scientific community, this is a horrible practice and unethical practice to have, because it means we don't actually understand the science that we're studying. It means that we're more or less kind of spitballing the hope that something lands. To give you all a more concrete example, it would be like if somebody were throwing darts at a board blindfold. They might hit every once in a while, but that doesn't mean they actually understand what's going on. They're lucky by coincidence is all that's happening here. Okay? So what we're up to today, implications of scientific and pseudoscientific behaviors, examining limits for scientific experimentation. Where do we draw a line on what is acceptable and what is not acceptable? And in the cases where a experiment is not acceptable because it's too risky or because it's too costly, but the outcome of the experiment could yield extremely positive benefits, how do we circumvent those risks? That's what we'll take a look at here as well. And how do we prevent such abuses of science? Unfortunately, science has been used for very nefarious and ill-intentioned purposes in the past. We'll take a look at some of those examples today. How do we prevent such things from happening again? AKA, how do we prevent history from repeating itself? So implications of unethical science. All right, some people are born to be a burden on the rest. This light flashes only every 16 seconds. Every 16 seconds, a person is born in the United States. Every 7.5 minutes, a high-grade person is born in the United States that will have the ability to do creative work and be fit for leadership. About 4% of all Americans come from this class. So this is an advertisement for a pseudoscientific movement in the early 1900s known as eugenics. Eugenics was pseudoscientific because it took a scientific, legitimate scientific research, eugenics, and genetics, and it tried to graft it on in order to justify extremely racist, extremely pseudoscientific, extremely prejudicial beliefs. The idea here that's given off by this advertisement is it says that the vast majority of people are lazy and we kind of need to cull the herd, hence why it says some people are born to be burden on the rest. Now, a person can look at this and they have extremely racist and immoral beliefs. They can say, well, I think person of XYZ race or person of XYZ ethnicity or XYZ sexual orientation is a burden on the rest. And now I have genetics here to support this. I can, even though if I don't understand genetics, I can say a person with this gene that gives them XYZ skin color or XYZ ethnicity, XYZ sexual orientation needs to be removed from society because science says that this gene is going to make them a burden on the rest. Now, obviously, that's not true. That's a person that's a person more or less shoehorning legitimate science in order to support their extremely prejudicial and racist beliefs, and that was the basis for the eugenics movement, which later became where is my little red marker at? Basis for eugenics movement, which later became the basis for Nazi purity laws, Aryan purity laws, and also for became the pseudoscientific justification for Jim Crow laws in the early to mid 1900s in the United States. Falsified data, okay? Unethical science, if data is falsified, we can have cases like this where we have measles outbreaks, okay? So back in 2018, there was a measles outbreak in the United States in several pockets across the United States, okay? There's 349 confirmed cases, 17 measles outbreaks, and then amongst those people, 1 in 4 were hospitalized, 1 in 1,000 had a chance of developing encephalitis, and 1 to 2 in 1,000 died, okay? So you may be asking yourself, 349 people of the whole United States, 1 in 4 people hospitalized, 1 in 1,000 will develop encephalitis, 1 to 2 in 1,000 will die. That's not bad. I'll take my risk on that, okay? I'll take my chances on that. But the thing, that's completely avoiding the point, okay? Statistics are statistics, yes, but the loss of any one life when it can be easily avoided and should be avoided is tragic, and it's horrible. And it's selfish, okay? This is an indirect consequence of the falsified study on vaccinations that we saw in this unit, okay? People in these pockets here were areas where people didn't tend to get their children vaccinated, and they said, oh, we'd just rely on herd immunity. Well, if we look at the statistic down here, 95% of a population has to be vaccinated, has to be inoculated in order to achieve herd immunity. That means if you have a population of 100 people, that means 95 people have to be vaccinated to have herd immunity. If you have a population of 1,000 people, 950 people have to be vaccinated. So essentially, it's more or less virtually 100% of the population has to be vaccinated, okay? And why this is so horrible is that there were people who died, children who died, and people who died, or if they didn't divide, they developed encephalitis, a severe medical condition, when this could have easily been avoided. If people weren't selfish, if people were educated about science, if people were thinking about the greater good, and they just followed health guidelines and had gotten their children vaccinated, this wouldn't have happened. And again, people look at this and go, well, it's not too bad. It's 1 in 1,000 will die, or 1 in 1,000 will develop encephalitis. But again, that's not the point. The point is because of people's selfishness and because of people's ignorance, other people are losing their loved ones because of something that could have been easily avoided. And then lastly, we look at experimentation, the most famous example, and there are some examples such as the Tuskegee incident that some of y'all will look at in our research activities for this lesson. But the most famous incident that most people, that beckons to mind when we think of dangerous experimentation is Nazi human experimentation back in the 1930s, 1940s during the Nazi regime in Germany. They tested that they would take people in the concentration camps and conduct unethical and extremely dangerous experiments on them without their consent or without informing these people of the risk of the experiments they're participating in. And even if these people had given their informed consent to be in the experiment, there still would be no reason for doing the experiment because the experiment was way too dangerous to carry out on any person regardless of whether that person was aware of the risk or not. People were exposed to vacuum chambers, which means they were in chambers where there was no oxygen, they couldn't breathe, and it is extremely painful. They were put in the gas chambers. Live surgeries were performed on people without anesthetic, meaning they could feel everything going on in the process. It was absolutely horrible and horrendous, and it was an egregious it's an egregious mistake on the record of humanity. And luckily, we've developed guidelines in response to this that will prevent that aim to prevent such things from happening again. Okay, but a big question that happened after the war is medical scientists in the United States and Allied forces, when they went into these concentration camps, they found the research being done. It was abhorrent. It was horrendous. It was downright grotesque. But at the same time, scientists looked at the results and said, well, there's some stuff we could use here for our own research. And so that begged the question, is it okay to use research that has been found from unethical and immoral means? And the answer to that question is no, in fact, emphatically not. And unfortunately, this is the moral ambiguity, the gray area that we face when we come to such cases. So implications of unethical science. Where'd my clicker go again? Okay. So science experiments throughout history have at times been conducted on humans in unethical/dangerous conditions, as we saw with Nazi experimentation, and as you will see in your research report activities for this lesson. In addition, scientific evidence can be abused at times to justify racist, immoral, or prejudicial beliefs, again, such as the Jim Crow laws or such as the Aryan purity laws of Nazi Germany. And then abuses of science can lead to public ignorance of devastating effects. Okay, the eugenics movement, a pseudoscientific movement that gained much steam in the early to mid 1900s, led to development of Jim Crow laws, which led to extensive racism. And the public were ignorant about this because they looked at eugenics and said, oh, if the public doesn't understand genetics, they're going to look at the eugenics movement and say, okay, these people know what they're talking about, I should follow them. And that has devastating effects because people become complicit in widespread racism. And then the most horrible example is genocide can also occur. Such was the case with Nazi Germany, although Nazi Germany is not the only case. There are other examples of genocides, such as the Armenian genocide and the Rwanda genocide, but the Nazi Germany genocide is the most well-known one, and also it's the one that maligned science in order to justify their ends. And so as a result, more than 6 million Jews were killed, and not just Jews, but also there were even more than the 6 million number refers just specifically to people of Jewish heritage, but there are even more people killed because they were crippled, they had developmental disorders, they're of a certain ethnicity, or they were homosexual, which was absolutely horrible. It's absolutely horrendous that such a thing happened. So how do we prevent? So we've looked at in the past couple of lessons how to prevent these last two bullet points, but we haven't really talked about how to prevent unethical or dangerous experiments. So how do we prevent unethical or dangerous experiments from happening? Okay, dangerous experiments are just quite frankly too dangerous to carry out or don't have enough scientific benefit. All right, so we have what are called grants and independent boards. So you may have heard the word grant before. To grant a person money is to reward them money, or to grant a person a gift is to reward them a gift. So in modern science, research requires funding, the same way that any endeavor you want to carry out in modern society requires money most of the time. So modern science research often requires funding, what we call a grant. So projects must be proposed to and approved by a scientific organization or receive the grant. And so this acts as a checks and balances to make sure that the experiments being conducted are safe. They're following specific guidelines, and they're not going to put anybody at risk. Okay. So if an experiment is too dangerous or too unethical to carry out, the scientific organization will not sign off of it, and that experiment will not receive money in order for it to be carried out and to be realized. So the project will fall flat on its face. So in addition, if a grant is given off to a project and the project does go astray and tend to become unethical or too dangerous after the grant is awarded, which can happen at times, unfortunately, we have independent boards and acts of legislation that have been passed by Congress that are used to monitor research activity by organizations and universities. Okay. So, for example, the Food and Drug Administration, the big one going on right now with the COVID-19 pandemic, they check all the data on any experimental trials for any new drugs or any new vaccines that are being developed, and they give the stamp of approval based on the data that they see for whether or not that drug should be, or vaccine or treatment should be made available to the public. So if the data shows that the treatment is safe, that it won't have any adverse effects on the public, any significant adverse effects, better said, and that it will yield many positive benefits for the public's health or for treatment of a specific disease, then the FDA will give their stamp of approval on that drug or treatment. Now, some of y'all may know, well, what about the commercials where they go, side effects may include blah, 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 blah. Unfortunately, in science, there always will be some side effects of treatments, but the FDA checks the data to make sure these side effects only occur in very, very, very rare cases, okay? Nuclear Regulatory Commission, okay? The Nuclear Regulatory Commission establishes safety guidelines for nuclear research and use. This is very important to establish very specific guidelines for nuclear engineering for the construction of nuclear power plants. So that way we don't have incidents such as the 3 Mile Island incident and the Chernobyl incident happening again. In addition, nuclear research is very valuable. It yields many, not from the purely scientific perspective, it yields many insights to how the nucleus of the atom works. But in an application-based perspective, it has many, nuclear physics, nuclear chemistry has many benefits for modern chemistry and for modern medicine and for energy production, as we've seen, okay? But the thing is that nuclear research can be very, very, very dangerous if specific guidelines aren't followed. So, for example, and I'm not a nuclear physicist myself, so I'm going to be kind of a little bit vague about this, not too specific. But if you bring two radioactive materials into close contact to each other and they touch each other, they can release a vast amount of radioactive radiation, or radioactive material, a vast amount of radiation. Now, you're not going to see this radiation. It's not going to look like an atom bomb, okay, or anything like that. But anybody in the immediate vicinity will feel the effects of this radiation, this invisible radiation. They'll become extremely nauseated. They'll start puking. They'll start going through all sorts of just convulsions, and it's not a pretty scene. And if that person's lucky enough to survive, they're probably not going to survive for long because the nuclear radiation will, in the long term, lead to the development of cancerous growths. So all that stuff is extremely dangerous, but the research is extremely worthwhile. So that's why we establish safety guidelines to follow in order to minimize the risk of such adverse health effects occurring. Okay. Let's see here. There, where is my little mouse again? Come on. There it is. Whoo, keeps disappearing on me. Lastly, we have the National Research Act, which was established as a result of the Belmont Report, which was written in 1979. This establishes ethical guidelines for human research, okay? Once we've tested out medical treatments on animals and made sure that, okay, the animals are good to go, then we'll move on to human phase, okay? But in order to make sure that the human phase is safe and that humans are not going to be put at significant risk, the clinical trials have to follow established ethical guidelines established by the National Research Act. Some of those guidelines include that the people involved have to be completely informed of all risk involved in the experiment, what the experiment is going to, what the experiment aims to do, and what the experiment entails. And then the people, based on that, have to give their consent. It's not enough that the person gives their consent at face value, because if a person's not aware of the risk of the experiment, then their consent is made with a significant amount of ignorance involved. All right, so people have to give their informed consent. They have to be informed of the risk and what's going to happen in the experiment, and then they have to consent for the experiment. As you all will see when you do your research activities for this specific lesson. So now this begs the question: what if we have an experiment that is really, if we could conduct it, what if we have research that if we could conduct it would yield a lot of positive benefits for people, but it's just too dang dangerous to carry out? Okay. Even more so dangerous than nuclear research, okay? And that is the case that happens. What do we do? Well, enter the matrix and welcome to the world of computer simulations. So experiments are too risky to perform, can now be simulated using computer simulations. So there are some experiments showcased by this guy in this video, called What is Calculus Used For?, where he talks about how simulations can be used to run simulations on how chemotherapy drugs are delivered to a person's lungs, because each person has very unique lungs, and the lung growth and lung development depends on the age of the person. So we can't just go test chemotherapy out on anybody if we don't know the correct dosage to give them. That can be dangerous. So we can design computer simulations based on calculus and mathematics that showcase what the dosage would look like and the effects would look like for a specific lung size and lung geometry. Okay. So this can lead to yielding very accurate predictions and very accurate results without requiring unethical or costly procedures or invasive procedures. In the video here, in addition, he talks about how they do scientific research into glaucoma, which is a condition that affects the eye, a medical condition that affects the eye. And he talks about how it's too dangerous to cut open a human eye and do so, because that would mean essentially destroying the eye of a living person. So what they can do is they can run a simulation that under certain conditions tells them what happens to a human eye under certain conditions where glaucoma may develop, based on the application of calculus and mathematics to develop computer simulations and programs. So this yields accurate predictions without requiring unethical or extremely costly procedures. The other thing too, the other side of it is that a procedure may not be unethical, but it may be too costly to carry out, meaning that there's just too much money involved and tied up in actually trying to carry out the actual procedure, which he also talks about in this video if you'd like to watch as well. And then sometimes you have to accept the good with the bad. We have to develop nuclear physics, for example, has many great benefits for humanity. Nuclear MRIs, again, being the one I've brought up the most since the day one of this class. But in addition, you also have nuclear weapons and nuclear proliferation, which is extremely dangerous and presents an existential threat to humanity. So what we have to do is develop guidelines and develop ethical procedures like we've been talking about in order to deter the bad while allowing the good to happen, kind of screening, kind of filtering out good from bad. So it's kind of like with driving. Driving has many benefits. It allows us to go see our families. It allows us to travel from place to place. But so it has many benefits, but at the same time there are many bad downsides to driving, such as the fact that pollutants get into our atmosphere, or if you're a person who is intoxicated behind the wheel of a car, they can do significant damage to people around them. So we have to develop guidelines in order to deter the bad and promote the good, is essentially what I'm saying. So our class activity is posted in Google Classroom for today if you missed the class activity. And this is our final topic for scientific literacy, scientific ethical standards.